Imagine you want to open a pizza restaurant. Not a digital one, a real brick-and-mortar place with cheese, sauce, the whole deal. You've got a few options. Option 1, you do everything from scratch. You buy the land, you construct the building, you install the plumbing and electricity. Then you go out and buy the giant pizza ovens, the refrigerators, the mixers, the tables, the chairs. And only then can you start thinking about buying the flour, the tomatoes, the pepperoni, and actually hiring a chef to make the pizza. The amount of upfront cost, the time, the risk, it's astronomical. Most people would give up before they even bought the first brick. Now, what if there was another way? What if you could just rent a fully equipped restaurant space? Someone else owns the building, they handle the electricity, and they've already installed the ovens and refrigerators. All you have to do is bring your ingredients and your recipes, and you can start cooking. That's a lot better, right? But what if we could make it even simpler? What if you could just walk into a shared kitchen, where not only are the ovens provided, but so are the pizza dough, the sauce, the cheese, and all the toppings. All you do is assemble your unique, signature pizza and bake it. You don't worry about where the flour came from, or if the oven is working. You just focus on making the best possible pizza. Or you could choose the easiest option of all. You just call a pizzeria, order a pizza, and have it delivered to your door. You don't own the building, you don't own the oven, you don't even provide the ingredients. You just enjoy a delicious, ready-to-eat pizza. This pizza analogy, that is the single best way to understand the cloud. Because that massive, complicated, and frankly intimidating world of cloud computing boils down to those same 3 choices. And by the end of this video, you will understand the 3 main types of cloud services: infrastructure as a service, platform as a service, and software as a service, so clearly that you'll be able to explain it to anyone. You'll finally know exactly which pizza option is right for your business, your project, or your career, and you'll be able to speak the language of modern technology with total confidence. The problem is, the tech world loves its jargon. IaaS, PaaS, SaaS. It's an alphabet soup of acronyms designed to make you feel like you're not in on the secret. You hear them in meetings, you see them in job descriptions, and most people just kind of nod along, hoping nobody asks them to explain the difference. This confusion isn't just harmless. It costs companies millions of dollars in bad decisions. It causes brilliant startup ideas to fail before they even begin. And it holds talented people back from seizing huge career opportunities. This video is the antidote to that confusion. We are going to cut through all of that noise. We're going to use our pizza restaurant analogy to break down each of these services, one by one. No dense technical diagrams, no boring definitions. Just a simple, powerful framework that will make it all finally click into place. And you need this to click because this isn't some niche, abstract concept anymore. This is the foundation of the modern American economy. Whether you're an entrepreneur in a garage in Palo Alto dreaming of building the next Netflix, a marketing manager in New York City trying to understand the tools your team is using, or a recent graduate in Austin trying to land a 6-figure job in the fastest-growing industry on Earth, understanding the cloud is no longer optional. It's the new literacy. It's the language of innovation, and if you don't speak it, you're at a massive disadvantage. To really appreciate the revolution, let's turn back the clock just 15 years. Back then, if you had a great idea for a website or an application, your first step wasn't writing code. It was going shopping. You had to physically buy computer servers. These weren't laptops. These were massive, heavy, power-guzzling metal boxes. You needed a dedicated air-conditioned room to store them, a server closet, or for bigger companies, a whole data center. You had to spend tens of thousands, sometimes hundreds of thousands of dollars just on this hardware. Then you had to pay someone to physically install it, to run all the cables, to set up the networking, to install the operating systems, and to manage the security. And your nightmare was just beginning. You needed a team of highly paid IT specialists on call 24/7, because when a hard drive failed at 3 a.m. on a Saturday, and it always did, your entire website would go down until someone could physically drive to the office and replace it. What if your website suddenly got popular? What if you got featured on the news and your traffic spiked by 1,000%? Your servers would crash. Your site would go down. And to fix it, you'd have to rush order more expensive servers, wait days for them to arrive, and go through that whole painful installation process all over again. By the time you were ready, the wave of traffic would be gone. You missed your shot. It was slow, it was incredibly expensive, and it was ridiculously risky. It created a world where only the biggest, most well-funded companies could afford to build powerful technology. Then, a few companies, most famously Amazon, had a world-changing idea. Amazon had already built one of the most massive, efficient, and powerful networks of data centers on the planet to run its own retail website. They had buildings the size of football fields packed with servers, with world-class security, cooling, and expert staff. Most of the time, though, they weren't using all of that computing power. So they thought, what if we just rented out slices of our infrastructure to other people over the internet? Instead of you having to buy your own server, what if you could just rent a virtual one from us for a few cents an hour? Instead of building your own data center, what if you could just use ours? You'd get all the power of a multi-billion-dollar infrastructure, but you'd only pay for exactly what you used. If you needed more power for a big traffic spike, you could get it instantly with the click of a button. When the traffic died down, you could click again and stop paying for it. This was the birth of the cloud. It wasn't a physical, fluffy thing in the sky. It was a business model. A shift from buying and owning technology to renting it as a utility, just like you rent electricity from the power company. This one idea completely democratized the internet. It leveled the playing field, allowing a couple of developers in a dorm room to have access to the same raw computing power as a Fortune 500 company. And it gave birth to the three main service models that run our digital world today. It all comes down to that one simple question we started with. How much of the pizza do you want to make yourself? Think about it. It's Friday night. You want pizza. You have a few options. Option 1. The traditionalist. You decide to make it completely from scratch. You go to the store and buy the flour, the yeast, the salt, the sugar. You buy whole tomatoes to crush for the sauce, a block of mozzarella to shred, fresh basil, pepperoni. You come home, you knead the dough and let it rise for hours. You simmer the sauce. You preheat your oven, the one you bought that you maintain that runs on the electricity you pay for. You assemble everything, you bake it, you clean up the massive mess. The result? A pizza that is exactly how you want it, down to the last grain of salt. You have total, absolute control over everything. But the effort? It's immense. The cost is high and the time commitment is huge. This is the old way of doing things in the tech world. We call it on-premises. You own the building, you buy the servers, you install the wiring, you manage the air conditioning, you buy and install the operating systems, and you build your applications. You control everything, and you are responsible for everything. Now let's look at option 2. You still want that custom artisan pizza, but you think, you know what? I don't want to buy, install, and maintain a professional-grade pizza oven. So instead, you rent time at a commercial kitchen. You walk in with your own perfect dough, your secret family sauce recipe, your hand-selected toppings. The kitchen provides the physical space, the electricity, the gas, and that beautiful roaring brick oven. You get to use their top-of-the-line infrastructure without having to own it. You just pay for what you use. You assemble your pizza on their counter, bake it in their oven, and take it home. This is infrastructure as a service, or IaaS. This is the foundational layer of the cloud. Companies like Amazon with its Amazon Web Services, or AWS, Microsoft with Azure, and Google with Google Cloud. They have built the world's biggest, most powerful commercial kitchens. They own the physical buildings, these massive secure data centers. They manage the power, the cooling, the networking, and the physical servers. And they rent out that raw infrastructure to you. With IaaS, you get a virtual slice of their hardware. You can spin up a virtual server, choose your storage, configure your network, all with a few clicks. You get the raw ingredients of computing, the processing power, the memory, the storage, without ever touching a physical box. Who uses this? Companies that need deep control. Maybe they have a highly specialized application that requires a specific older version of an operating system. Or they have complex security requirements that mean they need to manage their own virtual network from the ground up. They are the master chefs. They have their own unique recipe, their own way of doing things, and they don't want anyone interfering with that. But they're smart enough to know that building and running their own kitchen from scratch is a massive, expensive headache. So they rent the best kitchen in the world, the infrastructure, and bring their own ingredients to build on top. They are still responsible for managing the operating system, installing the software, patching for security vulnerabilities, and running their application. They've outsourced the hardware, but they still manage the software stack. That's IaaS. You manage the app and the platform it runs on. The cloud provider manages the physical hardware. Okay, but what if that's still too much work? Let's go to option 3 for our pizza. You think, I want to be creative with my pizza, but honestly, making dough is a pain. And simmering sauce for hours? I don't have time for that. So you find a service that delivers a high-quality pizza kit. They provide the perfectly proofed dough, the pre-made artisanal sauce, the shredded cheese. All you have to do is the fun part. Add your own unique toppings and bake it. You don't worry about the foundation. You just focus on what makes the pizza yours. In the cloud, this isn't just a kit they send to your house, they provide the oven too. They give you the platform and the place to build on it. This is platform as a service or PaaS. With PaaS, the cloud provider gives you even more. They don't just give you the raw servers and storage. They manage the operating system for you. They handle the security patches, the updates, the underlying databases, and the development tools. They give you a ready-made platform specifically designed for you to build, test, and deploy your own applications. All you have to bring is your code, your unique toppings. Think of a startup trying to build the next big social media app. Do they want to waste their small team's precious time configuring servers and updating operating systems? Absolutely not. They want to spend every waking minute writing the code that makes their app special. PaaS is their secret weapon. Services like Heroku or Google App Engine let a developer write their code, hit a button that says deploy, and the platform handles literally everything else. It automatically figures out how much server power is needed, configures the network, and makes the app live on the internet. It's an incredible accelerator for innovation. The developer is still the chef, but they're a very specialized chef. They're not worried about making the dough or the sauce. They are focused exclusively on the art of combining the toppings, their code, to create a masterpiece. They are responsible for their application, but the entire underlying platform is managed for them. That's PaaS. You manage the app. The cloud provider manages the platform and the hardware. Now for the final and most common option. It's Friday night, you're exhausted, and you say, I just want a pizza. You don't want to buy ingredients, you don't want to assemble anything, you don't even want to turn on your oven. You pick up your phone, open an app, tap a few buttons, and 30 minutes later, a hot, delicious pizza arrives at your door. You didn't make it. You didn't manage any part of the process. You are simply consuming the final product as a service. This is software as a service or SaaS. This is the cloud you use every single day, probably without even thinking about it. When you open Gmail to check your email, you are using SaaS. You don't manage the email servers, the software, or the security. Google does all of it. You just use the software through your web browser. When you binge watch a show on Netflix, that's SaaS. When you collaborate with your team on Slack or Microsoft 365, that's SaaS. When you manage your sales leads in Salesforce, that's SaaS. The entire product, the hardware, the platform, and the software itself is built, managed, and delivered to you over the internet by a company. You typically pay a monthly or yearly subscription and you just use it. You have the least amount of control. You can't change the core features of Gmail, but you also have zero management responsibility. You're just the hungry customer enjoying the pizza. So let's put it all together. On premises, you build the kitchen, buy the ingredients, and make the pizza from scratch. Maximum control, maximum work. Infrastructure as a service, IaaS, they provide the kitchen and the oven. You bring your own ingredients and make the pizza. You control the recipe and the final product. Platform as a service, PaaS, they provide the kitchen, oven, dough, and sauce. You just add your creative toppings and bake it. You control the application you're building. Software as a service, SaaS, you just order a pizza. They do everything. You just eat it. You have no control over how it's made, you just consume the service. This progression from IaaS to PaaS to SaaS is a journey of increasing abstraction. At each step, you hand over more responsibility to the cloud provider in exchange for more convenience and focus. But this isn't just about convenience. This pizza delivery system completely rewired the global economy, and understanding who controls the kitchen and who controls the recipe reveals the hidden power dynamics of the 21st century. Let's peel back the first layer of this new digital world, starting with the most fundamental, the most powerful, and the most hands-on model. Think of it as the bedrock upon which everything else is built. This is infrastructure as a service, or IaaS. To understand IaaS, let's go back to our pizza analogy. Imagine you decide you want to start a pizza business. The old-fashioned way, the pre-cloud way, is to do everything yourself. This is what we call on-premise. You have to buy or lease a building. You have to run the gas lines and the electrical wiring. You have to purchase the commercial-grade ovens, the giant refrigerators, the stainless steel prep tables, and all the cooking utensils. You are responsible for paying the utility bills, for fixing the oven when it breaks, for calling an exterminator, for mopping the floors. You have total control, yes, but you also have total responsibility and a massive upfront cost before you've even sold a single slice of pizza. This is how companies used to run their IT. They built their own data centers, massive, expensive, power-hungry buildings filled with servers, networking gear, and cooling systems. It was a huge capital investment, a barrier to entry that only the biggest players could afford. Now imagine a different option. A new company opens up downtown called Cloud Kitchens Incorporated. They've built a state-of-the-art, massive commercial kitchen. It has hundreds of top-of-the-line pizza ovens, refrigerators, and prep stations, all maintained 24/7. They handle the electricity, the gas, the rent, the security, the cleaning. You don't have to buy a thing. Instead, you can just rent a station in their kitchen. You can rent it by the hour, by the day, or by the month. You get access to the oven, the fridge, the workspace, all the essential infrastructure. This is infrastructure as a service. You don't own the kitchen, you just use it. But here's the crucial part. Cloud Kitchens Incorporated doesn't give you any ingredients. They don't give you a recipe. You have to bring your own dough, your own secret family sauce recipe, your own cheese blend, your own pepperoni. You are still responsible for assembling the pizza, for cooking it perfectly, and for creating a product that people actually want to buy. You have complete control over your recipe and the final product, but you've outsourced the headache and the enormous cost of building and maintaining the physical kitchen. That is exactly what IaaS is. Companies like Amazon with AWS, Microsoft with Azure, and Google with Google Cloud Platform have built these unimaginably massive, global data centers, the digital equivalent of our cloud kitchen. And they rent out the fundamental building blocks of computing over the internet. So what are these building blocks? It mainly comes down to three things. First is compute. This is the processing power. In our analogy, this is the oven. With IaaS, you're not renting a physical server. You're renting a virtual server, or what's called a virtual machine, a VM. Think of it like this. Amazon has a server that is so colossally powerful it would be like a pizza oven the size of a football field. You don't need that whole oven. So they use virtualization technology to slice that one giant oven into thousands of smaller, private, virtual ovens that all run independently. You can rent one of these virtual ovens, choose how hot it gets, meaning how much processing power it has, and you only pay for what you use. Second is storage. This is your digital refrigerator and pantry. It's where you keep your data, your dough, your sauce, your toppings. IaaS providers offer incredibly durable and scalable storage. You can start with a small shelf in the fridge, and as your business grows, you can instantly rent more and more space, to the point where you have a whole warehouse without ever having to buy a new physical hard drive. And third is networking. These are the virtual wires, switches, and routers that connect your compute and storage together and connect them to the internet. It's the internal logistics of your kitchen space, ensuring your prep table can get ingredients from the fridge and your finished pizza can get out the door to the customer. With IaaS, you, the customer, are in charge of everything above this basic infrastructure. You have to install the operating system, whether that's Windows or Linux. You have to install the database software. You have to install all the tools and code that make up your application. You are the chef. You control the entire cooking process. The IaaS provider just makes sure the oven is on and the lights stay lit. This brings us to one of the most important concepts in all of cloud computing: the shared responsibility model. The IaaS provider, like Amazon, is responsible for the security of the cloud. They secure the physical data centers with guards and fences, they ensure the hardware is running correctly, and they protect the network from outside physical threats. They are responsible for the kitchen building itself. But you are responsible for security in the cloud. You are responsible for who has the keys to your rented kitchen space. You have to make sure you're using strong passwords, that you're patching your operating system against viruses, that you're not leaving your secret sauce recipe lying out on the counter for a competitor to steal. It's a partnership in security, and misunderstanding this is one of the biggest mistakes companies make when they move to the cloud. So who uses this? Why would you want this level of control and responsibility? The most famous example is Netflix. For years, Netflix ran its own data centers, but as they exploded in popularity and wanted to go global, they made a historic decision to move their entire streaming service to Amazon Web Services, an IaaS platform. Why? Scalability. When a new season of The Crown drops, tens of millions of people hit play at the same time. The demand on their servers is astronomical. If Netflix ran its own data center, they would have to build it big enough to handle that absolute peak demand, a peak that might only last for one weekend. The rest of the year, all that expensive equipment would sit there, mostly idle, costing them a fortune. With IaaS, Netflix can just rent 1,000 extra virtual ovens for Friday night, and then on Monday morning when demand drops, they can just give them back. They only pay for the massive capacity when they actually need it. This elasticity is a superpower. It allowed Netflix to expand to 130 countries in a single day, a feat that would have been physically and financially impossible in the old on-premise world. It's also a lifeline for startups. Before IaaS, if you had a brilliant app idea, you'd need to raise hundreds of thousands of dollars just to buy the servers to get started. Now you can swipe a credit card, rent a small virtual server on AWS for a few cents an hour, and launch your idea to the world from your garage. IaaS demolished the barrier to entry for building a tech company, but it comes with a trade-off. While IaaS gives you the ultimate flexibility and control, it also carries the most complexity. You need a team of highly skilled engineers, your master chefs, who know how to manage operating systems, configure virtual networks, and patch databases. You're not building the kitchen from scratch, but you are still doing all the cooking, and you're responsible for cleaning your own station. This level of control is incredible. It's the foundation of the modern internet. But it begs the question, what if you're not a five-star chef? What if you don't want to worry about managing operating systems or configuring databases? What if you're a brilliant baker who just wants to focus on creating the world's greatest pizza, without ever having to think about preheating the oven, cleaning the equipment, or even buying the dough? What if someone could provide not just the kitchen, but the pre-made dough and basic ingredients too, so all you have to do is add your unique, creative toppings and cook? That desire for even more convenience, for more focus on the final product, leads us to the next, and perhaps most revolutionary layer of the cloud. It's the platform that allows a single developer to build an application that can serve millions of people, and it's where we're going next. This next layer is called Platform as a Service, or PaaS. And if IaaS was like renting an empty kitchen to cook in, PaaS is like ordering a pizza for delivery. Think about it. When you order from Domino's or Pizza Hut, what do? You pick up the phone or open an app, and you make one decision: the toppings. You say, I want a large thin crust with pepperoni, mushrooms, and extra cheese. That's it. Your work is done. You don't care about the brand of oven they use. You don't care if their fridge is at the right temperature. You don't manage their dough supply, you don't slice the pepperoni, you don't grate the cheese, and you certainly don't worry about cleaning the kitchen afterwards. All of that, the infrastructure, the platform, the ingredients, the process, is handled for you. You just provide the creative input, the toppings, and a finished, hot, ready-to-eat pizza shows up at your door. That is exactly what Platform as a Service does for software developers. With IaaS, we rented the servers, storage, and networking, the raw kitchen appliances. But we still had to do a ton of work. We had to install the operating system like Linux or Windows. We had to install the web server software, the database, the programming language environment, all the digital ingredients and prep work. PaaS says, forget all that. Just give us your code. A PaaS provider like Heroku or Google App Engine gives a developer a complete, ready-made environment to run their application. The operating system, managed for you. The security patches for that operating system, handled. The web server needed to accept incoming traffic, already configured. The database you need to store user data, available with a single click. The ability to handle one user, or 1 million users. It's built in. The developer's only job is to write the code for their actual application. The unique features that make their software special. That's the pepperoni and mushrooms. They upload that code to the platform, and the PaaS provider does everything else. They effectively put the toppings on the pizza, bake it at the perfect temperature, put it in a box, and deliver it to the entire world. This was an absolute game changer. Before PaaS, if you were a brilliant programmer with a world-changing app idea, you still had to become a part-time systems administrator. You had to learn how to configure servers, manage databases, and set up complex networks. It was a massive barrier. It was like telling a world-class painter they had to first build their own canvas and mix their own pigments from scratch before they could even start painting. PaaS blew that barrier to pieces. One of the most famous early examples is a company called Heroku. Their slogan might as well have been "just push your code." A developer could write an application on their laptop, and with a single command, literally git push Heroku master, that application would be live on the internet, ready to serve users globally. Behind the scenes, Heroku was automatically configuring servers, setting up databases, balancing traffic, doing all the brutally complex work that used to take a whole team of experts weeks to accomplish. Suddenly, a single person in their dorm room could build and launch a service that could potentially scale to millions of users. This unleashed a tidal wave of innovation. Startups could now go from an idea to a functioning product in record time, with a fraction of the cost and manpower. They could focus their limited resources on what actually mattered, building a great product that customers loved, instead of building and managing a data center. So what are the big advantages here? The first, as we've seen, is speed. The time it takes to go from a line of code to a live application shrinks from weeks or months to minutes or hours. This allows companies to experiment, to iterate, to fail fast and try again, which is the lifeblood of innovation. The second is focus. PaaS allows developers to be developers, not infrastructure managers. It removes the undifferentiated heavy lifting. Your competitors are using the same servers, the same databases, the same networks. You don't win by being slightly better at managing a Linux server. You win by having a better product. PaaS lets you put 100% of your energy into that winning product. And third, it provides effortless scale. In the old world, if your app suddenly got featured on the front page of the news and a million people tried to use it at once, your servers would crash. Your site would go down. Your moment of glory would become a moment of failure. With PaaS, the platform is designed to handle this. It can automatically add more computing power, more servers, more resources as traffic spikes, and then scale them back down when the traffic subsides. This elastic scaling is incredibly powerful and incredibly difficult to build yourself. But as with everything, there are trade-offs. This convenience comes at a cost, and that cost is control. When you order from Domino's, you can't go into their kitchen and tell them to use a specific type of Italian flour for the dough, or to crank their oven up to 900 degrees for a perfect Neapolitan char. You are limited to the options on their menu. You get their dough, their sauce, their oven. It's the same with PaaS. You are building on top of the provider's platform, using their tools, their rules, and their specific way of doing things. You usually can't install custom, low-level software or tweak the operating system kernel. If your application has a very unique, very specific requirement that the platform doesn't support, you might be out of luck. This leads to the biggest concern with PaaS: vendor lock-in. When you write your application to run on a specific PaaS, you are often using that provider's proprietary services and APIs for things like databases, user authentication, or file storage. Your code becomes deeply intertwined with their ecosystem. Now, imagine 5 years later, that provider decides to double their prices. Or maybe a competitor comes out with a much better, cheaper platform. Moving your application from one PaaS to another isn't like just uploading your code to a new place. It can require a massive, expensive, and time-consuming rewrite of large parts of your application. You're locked in. You've built your house on their land, and moving it is next to impossible. So, the choice between IaaS and PaaS is a fundamental strategic decision. IaaS gives you maximum control and flexibility. You are renting the raw kitchen. You can install any oven you want, use any ingredients, cook any recipe imaginable. But you are responsible for everything: the setup, the maintenance, the cleaning, the security. It requires more expertise and more hands-on management. PaaS gives you incredible speed and convenience. You are ordering pizza delivery. You get to focus entirely on the creative part, the toppings, and you get a finished product delivered instantly. But you give up control and you risk getting locked into that one pizza place for a very, very long time. For many new projects, startups, and developers, the speed and focus offered by PaaS are a godsend. It's the engine that powered much of the web and mobile app explosion over the last decade. It put world-class infrastructure into the hands of everyone. But for many people, both in business and in their personal lives, even this is too much involvement. Many people aren't developers. They don't want to write code. They don't want to choose toppings. They are simply hungry and they want to eat a pizza that is already made. They just want to open the box and have the final, complete product. Ready to use, no assembly required. This brings us to the highest level of abstraction, the layer of the cloud that virtually every single person listening to this uses every single day, whether they realize it or not. This is the finished product, the fully managed service, the final frontier of cloud computing. We call this software as a service, or SaaS. Let's go back to our pizza shop one last time. In our first scenario, infrastructure as a service, we rented the raw kitchen space and appliances. We had to bring our own ingredients, our own recipe, and our own staff to cook. Maximum control, maximum work. In our second scenario, platform as a service, we got the kitchen, the appliances, and the ingredients. All we had to do was bring our recipe and cook the pizza. A perfect middle ground. But now, with software as a service, you're not even going into the kitchen. You're not cooking. You're not even picking up the pizza. You're sitting on your couch, you pull out your phone, you open an app like Domino's or Pizza Hut, you tap a few buttons to order a large pepperoni, and about 30 minutes later it arrives at your door. You don't manage the oven. You don't manage the ingredients. You don't manage the cooks or the delivery driver. You are simply consuming the final finished product. You are getting pizza as a service. That is SaaS. It's the most abstracted, most hands-off, and most common form of cloud computing. SaaS is a method of delivering software applications over the internet, on demand, and typically on a subscription basis. You don't buy it, you don't install it, you don't own it, you rent access to it. The single greatest example of SaaS, one that nearly every person on earth has used, is web-based email like Gmail or Outlook.com. Think about what's actually happening when you use Gmail. You open your browser, type in the address, and you're in. You can send, receive, and store thousands of emails with massive attachments. But what didn't you have to do? You didn't have to buy a physical server and put it in a rack. You didn't have to install and configure a complex operating system like Linux. You didn't have to install and painstakingly configure an email server program like Microsoft Exchange or Postfix. You didn't have to worry about managing terabytes of storage for all those emails. You didn't have to set up antivirus and anti-spam systems to protect yourself. You didn't have to worry about keeping the server online 24/7 through power outages and internet failures. You didn't have to do any of that. Google did it all for you. All of that complex infrastructure and software, the servers, the networking, the operating systems, the email platform itself, is completely invisible to you. You just consume the end product, the ability to send an email. That is the power and simplicity of SaaS. And it is everywhere. You are swimming in an ocean of SaaS every single day. When you stream a movie on Netflix or a song on Spotify, you're using SaaS. You pay a monthly fee and they deliver content to you. You're not managing the massive video files, the encoding software, or the global content delivery network. You just press play. When you collaborate with your team on Slack, share files on Dropbox, or hold a meeting on Zoom, you're using SaaS. The software lives in the cloud, and you access its functionality through an app or a web browser. When a massive corporation manages its customer relationships using Salesforce, or its finances using NetSuite, that's SaaS. These companies are paying millions of dollars a year to not have to build and manage these incredibly complex systems themselves. They are outsourcing the entire software stack to a provider who specializes in it. Even the most fundamental productivity tools have become SaaS. Remember the old days? You'd go to Best Buy and purchase a box for Microsoft Office. You'd take it home, install it from a CD-ROM, and you'd have that version of Word and Excel forever. If a new version came out, you had to go buy another box. Today, you subscribe to Microsoft 365 or Google Workspace. For a monthly fee, you get access to all the latest versions of Word, Excel, PowerPoint, Docs, Sheets, and Slides. You can access them from any computer, any phone, anywhere in the world with an internet connection. Your documents are saved to the cloud automatically. That entire business model, the shift from a one-time purchase to an ongoing subscription, was driven by the SaaS model. This shift has profound benefits for both the user and the provider. For us, the users, the upfront cost is dramatically lower. Instead of a $400 one-time fee, it might be $10 a month. We also get continuous updates automatically, so we're never running outdated, insecure software. And of course, there's the accessibility from anywhere. For the software provider, the benefits are even bigger. They get a predictable, recurring revenue stream, which is Wall Street's favorite thing in the world. They can push updates, bug fixes, and new features to all their users instantly, without having to manage thousands of different installed versions. And it dramatically reduces software piracy. It's a win-win that has fundamentally reshaped the entire software industry. So, let's look at our responsibility chart for the last time. With infrastructure as a service, the vendor managed the bottom layers, the physical stuff, and you manage the top layers from the OS on up. With platform as a service, the vendor managed even more, up through the runtime and middleware, leaving you to manage just your application and data. With software as a service, the vendor manages everything. Everything. The networking, the storage, the servers, the virtualization, the operating system, the middleware, the runtime, and even the application and data management itself. The entire stack is their problem. What do you manage? You manage who has access to the software. You configure the settings inside the application to suit your needs. And that's it. Your responsibility is minimal because you're just using the finished product. You're a customer at a restaurant, not the chef in the kitchen. To truly appreciate this, you have to remember what it replaced. The old model is called on-premise software. This is where you or your company were responsible for the entire stack. You bought the servers, you racked them in your own data center, you installed the OS, you installed the database, you installed the application, you managed the licenses, you performed the backups, you handled the security patches, you replaced failed hard drives at 3 a.m. It was, and for many applications still is, an incredibly expensive and complex undertaking, requiring a whole team of specialized IT professionals. SaaS takes that entire mountain of work and complexity and abstracts it away behind a simple login screen and a monthly credit card charge. It has democratized access to incredibly powerful software. A small startup of 2 people can now use the exact same world-class CRM, accounting, and collaboration tools as a Fortune 500 company, something that would have been financially and technically impossible just 20 years ago. So there you have it. The 3 main service models of cloud computing. IaaS, the foundation. The raw building blocks of computing power, storage, and networking that you rent and build upon yourself. It's like renting the kitchen. PaaS, the middle layer. The platform that handles the underlying infrastructure, letting you focus solely on building and running your applications. It's like using a take-and-bake pizza service. And SaaS, the final product. The ready-to-use software that you access over the internet, where everything is managed for you. It's the pizza delivered right to your door. Each layer provides a different level of control, flexibility, and ease of use. But here's the critical question. How do you choose? How do real companies, from tiny startups to giants like Netflix, decide which service model to use? And is it really as simple as just picking one? The answer is no. The true power of the cloud isn't just in these individual layers, but in how they can be strategically combined to build things that were never before possible. Let's think about this not as a choice, but as a strategy. This isn't about picking one lane and staying in it forever. It's about building a stack, a technology stack. Imagine you're building a skyscraper. You don't build the entire thing out of glass. You need a deep foundation of concrete and steel, a flexible framework for the floors, and a beautiful glass facade for the exterior. Each material has a purpose. IaaS, PaaS, and SaaS are your building materials for the digital world. To make this crystal clear, let's leave the world of pizza and cars and build a fictional company from the ground up. Let's call them NextGen Fitness. Their big idea is to create a hyper-personalized workout and nutrition app, powered by artificial intelligence. It's day one. The founders, a personal trainer and a software developer, are working out of a garage. They have a revolutionary idea, but they have almost no money. What's the first thing they need? They need to exist. They need a website to explain their vision, a way to collect email addresses for a waitlist, and a professional email address so they don't look like amateurs. Do they go out and rent a raw server from an IaaS provider, install Linux, configure a web server, set up an email server, and then start coding a website from scratch? Absolutely not. That would be like trying to build a new car just to drive to the grocery store. It would take them months and burn through all their cash. Instead, they turn to software as a service. Within an afternoon, they've used Squarespace to create a stunning landing page. They've signed up for Google Workspace, giving them professional email, cloud storage with Google Drive, and collaboration tools like Docs and Sheets. They use MailChimp to manage their email list. For a couple $100s a month, they have a complete, professional-grade operational toolkit. They haven't written a single line of code or worried about a single server. They are 100% focused on their product and their potential customers. This is the power of SaaS at the ground level. Immediate access to world-class tools for a low, predictable monthly fee. They are renting the finished car, and it's getting them exactly where they need to go. Fast forward 6 months. NextGen Fitness has a huge wait list. They've secured some initial funding. It's time to actually build the app. This is their secret sauce. It needs a custom algorithm to analyze user data and generate unique workout plans. It needs to connect to smartwatches and fitness trackers. It needs a user-friendly interface. This is something they can't just buy off the shelf. Squarespace can't do this. This requires custom code. So do they now turn to IaaS? Do they rent a bunch of virtual machines, install operating systems, configure databases, set up load balancers, and manage network security, all before their developer can even start writing the first line of the app's code? Again, no. That would be a massive distraction. Their small development team would spend 80% of their time being system administrators and only 20% of their time building the actual product that makes their company unique. The value of NextGen Fitness isn't in their ability to configure a PostgreSQL database. It's in their fitness algorithm. This is the perfect moment to climb the ladder of abstraction to platform as a service. They choose a provider like Heroku or AWS Elastic Beanstalk. This is their pre-built workshop. The PaaS provider handles everything underneath the code. The servers, the networking, the operating system, the database management, it's all managed for them. Their developer can simply write the code for the next-gen fitness app and push it to the platform. The PaaS automatically handles the deployment, scaling, and maintenance. If the app suddenly gets 1 million users because it's featured on a morning talk show, the PaaS can automatically spin up more resources to handle the load, and then scale back down when traffic subsides. They are no longer just renting a car. They're renting a fully equipped, fully staffed auto shop where they can focus exclusively on designing and building their own unique, high-performance engine. All the wrenches, the lifts, the diagnostic tools, it's all there for them, ready to go. This use of PaaS allows them to build and launch their custom application in record time, focusing their talent and money on what truly matters: their code. Now let's jump forward 2 years. Next-Gen Fitness is a wild success. They have millions of active users. Their app is a hit, but they've hit a new kind of problem. A good problem, but a complex one. They are now collecting an unimaginable amount of data. Billions of data points every single day about workouts completed, calories consumed, sleep patterns, heart rate variability, and more. Their original AI was good, but now they see the potential for something revolutionary. They want to build a predictive health engine, an AI that can not only suggest a workout for today, but can analyze your long-term data to potentially flag health risks or predict athletic plateaus before they happen. This is a different beast entirely. This kind of massive-scale machine learning requires a very specific and powerful type of computing environment. They need fleets of virtual machines equipped with high-end GPUs or graphics processing units, which are essential for deep learning. They need ultra-fast networking between these machines for distributed processing. They need complete, granular control over the software environment to install specialized AI frameworks and custom-compiled libraries. The pre-built workshop of a PaaS is now too restrictive. A PaaS is designed for general-purpose web applications. It's not optimized for this kind of specialized, high-performance computing. It's like trying to build a Formula 1 race car in a standard Jiffy Lube. You don't have the right tools or the right level of control. This is the moment they finally embrace infrastructure as a service. They go to a provider like Amazon Web Services, Google Cloud, or Microsoft Azure, and they start renting the fundamental building blocks. They rent raw virtual servers, but they get to choose the exact specifications. This one needs 64 CPU cores, this one needs a terabyte of RAM, and this fleet of 100 machines each needs an NVIDIA A100 Tensor Core GPU. They are now responsible for much more. They have to install the operating systems, configure the networking, manage the security patches, and install all the software themselves. It's a huge increase in complexity and requires a dedicated team of infrastructure engineers. But in exchange for that complexity, they get ultimate power and flexibility. They are no longer renting the workshop. They are now leasing the land and building their own custom, state-of-the-art manufacturing plant, designed for one purpose and one purpose only: to build the most advanced predictive health engine in the world. So look at what they've built. Next-Gen Fitness is not an IaaS company or a PaaS company. They are a cloud-native company that uses the entire stack. They still use Squarespace for their marketing blog, a SaaS. They still use Google Workspace for their corporate email, a SaaS. Their main customer-facing mobile app still runs happily on a PaaS because it's efficient and easy to manage. And their highly specialized, data-intensive AI research and development happens on IaaS, where they have the raw power and control they need. Each layer serves a different purpose, at a different stage of the company's life, and often, all at the same time. They are using the right tool for the right job. This strategic combination is the true genius of modern cloud computing. It's a spectrum of control versus convenience, and businesses can slide up and down that spectrum depending on their specific need for any given project. They get the speed and simplicity of SaaS for their standard business needs, the rapid development power of PaaS for their unique applications, and the raw, unadulterated control of IaaS for their most ambitious, world-changing ideas. This hybrid approach, this mixing and matching, is the secret sauce of modern IT. It's how companies stay agile, innovative, and competitive. But it also introduces a critical question, one that's often overlooked until it's too late. When you're using all these different services, from a simple SaaS application to a sprawling IaaS environment, who is responsible for what? If something goes wrong, a security breach, a data loss, a system crash, where does the buck stop? With you or with the cloud provider like Amazon, Google, or Microsoft? The answer to this is one of the most fundamental concepts in cloud computing. It's called the shared responsibility model. And understanding it isn't just a good idea. It's absolutely essential. It's the invisible contract that defines your job versus their job. Getting this wrong can lead to catastrophic security failures, compliance nightmares, and budget-breaking disasters. Think of it as a line drawn in the sand. On one side, you have the responsibilities of the cloud provider. On the other side, you have the responsibilities of the customer, that's you. The position of that line changes dramatically depending on whether you're using IaaS, PaaS, or SaaS. Let's start at the foundation with infrastructure as a service, or IaaS. Here, the provider's responsibility is for the security of the cloud. What does that mean? They are responsible for the physical stuff. The concrete data centers with their security guards, biometric scanners, and backup generators. They're responsible for the physical servers, the storage arrays, the networking cables, and the cooling systems. They manage the hardware and ensure that the virtualization layer, the software that creates the virtual machines, is running and secure. Essentially, they promise to give you a functioning, secure virtual piece of their data center. But that's where their responsibility ends. With IaaS, you, the customer, are responsible for security in the cloud. And that is a huge list. You are responsible for absolutely everything you put on that infrastructure. You have to choose the operating system, install it, and crucially keep it patched and updated. A new vulnerability discovered in Windows Server or Linux. That's on you to fix. You are responsible for the middleware, the runtime environments, and all the application code. Most importantly, you are responsible for your data. You control its classification, its encryption, both in transit and at rest, and who has access to it. You are responsible for configuring the network security, the firewalls, the access control lists, and the identity management. You're renting a powerful, empty digital warehouse. The landlord, your cloud provider, ensures the building is earthquake-proof and has a working power grid. But you are responsible for what you put inside, the locks you put on your storage units, and who you give the keys to. This is the ultimate control we talked about, but it comes with the ultimate responsibility. Now let's move up the stack to platform as a service, or PaaS. The line of responsibility shifts significantly. The cloud provider now takes on much more of the management burden. They are still responsible for all the physical infrastructure, just like in IaaS. But with PaaS, they are also responsible for managing the underlying operating system. You don't have to worry about patching Windows Server anymore. They handle it. They also manage the middleware, the development tools, and the runtime environments. If there's a critical security update for the Java or Python runtime you're using, the PaaS provider deploys that fix for you. Their job is to provide you with a stable, secure, and up-to-date platform on which you can build and run your applications without ever having to think about the underlying system administration. So what's left for you? Your responsibility is now focused on two key things: your application and your data. You write the code, you deploy the application onto the platform, and you are responsible for the security of that code. You are also, once again, responsible for the data that your application processes and stores, and for managing who has access to it. With PaaS, the landlord doesn't just give you an empty warehouse. They give you a fully equipped, state-of-the-art workshop. It has a workbench, power tools, and lighting, all maintained and kept in perfect working order by the landlord. Your job is to come in and use those tools to build your masterpiece. You're still responsible for the quality and security of what you build, and for not leaving the blueprints lying around for anyone to steal, but you don't have to worry about maintaining the tools or fixing the electricity. Finally, we arrive at software as a service, or SaaS. Here, the line shifts almost completely over to the provider. The SaaS provider, like Salesforce, Google, or Microsoft with Office 365, manages almost everything. They manage the physical data centers, the servers, the networking, the storage. They manage the operating systems, the middleware, and the runtime. And, critically, they also manage the application software itself. They are responsible for developing the software, adding new features, fixing bugs, and pushing out security patches. When a new version of Gmail or Dropbox is released, you don't have to do anything. It just happens. The provider is responsible for the availability, performance, and security of the entire service, end to end. So, what on earth is left for you to be responsible for? It comes down to two simple but critically important things: your data and your users. You are responsible for the information you choose to upload and create within that SaaS application. And you are responsible for managing access. Who in your company gets an account? What level of permissions do they have? Can they share documents externally? You control the user accounts and the configuration settings that the SaaS provider makes available to you. Think of SaaS as renting a fully furnished, all-inclusive apartment in a high-security building. The building management handles everything: the structure, the electricity, the plumbing, the furniture, even the cleaning service. Your sole responsibility is to manage your own belongings inside the apartment and to be careful about who you give a key to. Google is responsible for making sure no one can break into their servers to steal all of Gmail's data. But you are responsible for not falling for a phishing email and giving your password away to a scammer. That user-level security is always on you. This shared responsibility model is the framework that holds the entire cloud ecosystem together. In IaaS, the provider manages the ground, and you build the entire house from the foundation up. In PaaS, the provider builds the house, and you handle the interior design and furnishing. In SaaS, the provider builds and furnishes the house, and you just live in it, responsible only for your own personal property and who you invite inside. Understanding this distinction is not just academic. It has massive real-world consequences. If you're using IaaS and you fail to patch your virtual server, and a hacker gets in and steals customer data, that is 100% your fault. You can't blame Amazon or Microsoft. Conversely, if a vulnerability is found in the Salesforce platform itself that exposes customer data, that responsibility lies with Salesforce. Knowing where that line is drawn dictates your security strategy, your staffing needs, your budget, and your compliance posture. It tells you whether you need to hire a team of expert system administrators or just a single person to manage user accounts. So the lines are drawn. In IaaS, you're the architect and the builder. In PaaS, you're the interior designer. And in SaaS, you're the tenant. But knowing your role is only half the battle. The real question is, how do you decide which house to build, which room to design, or which apartment to rent in the first place? How do you match the right service model to the right job to solve your specific problem? That's where the real strategy comes in. Let's break it down using a simple but powerful framework: the spectrum of control versus convenience. Think of it as a sliding scale. On one end, you have absolute, granular control over every single component. On the other end, you have ultimate, effortless convenience. Every decision to use IaaS, PaaS, or SaaS is a decision about where you want to be on that spectrum. Let's start at the far left end: maximum control. This is the world of IaaS. This is for the master builders, the architects who need to lay their own foundation because no pre-built one will do. You choose IaaS when the how is just as important as the what. You don't just want a database. You need a specific version of a specific database, running on a specific operating system, with a custom-tuned file system and a highly specific networking configuration. So, who are these people? First, think of high-performance computing. We're talking about massive, complex calculations that push the limits of technology. Imagine a pharmaceutical company running simulations to discover a new drug. They need to spin up a cluster of thousands of virtual machines, each with a very particular type of GPU, a graphics processing unit, optimized for scientific calculations. They need to control the low-level network traffic between these machines to minimize latency. A PaaS or SaaS solution would be a straitjacket. It wouldn't offer the raw, untamed power they need. They need the bare metal, the virtualized hardware of IaaS, to build their computational empire. Another huge use case for IaaS is what the industry calls lift and shift. This sounds technical, but the concept is simple. Imagine a large, established bank. For 20 years, they've been running a critical software application on their own servers in their own data center. This software is a beast. It's old, it's quirky, it was written by developers who have long since retired, but it works and the entire business depends on it. The bank wants the benefits of the cloud, they want to stop buying and maintaining physical servers, and they want the ability to scale up during peak financial reporting seasons. But rewriting that 20-year-old application is a monumental, multi-year, multi-million-dollar project they're not ready for. So what do? They perform a lift and shift. They take an exact copy, a snapshot of their old servers, the operating system, the weird configurations, the application itself, and they lift it up and shift it over to run on virtual machines in an IaaS cloud. They've essentially just rented a new, better, more flexible basement to run their old stuff in. They haven't changed the application, but they've escaped the prison of managing their own hardware. This is one of the single biggest drivers of IaaS adoption in the world. So the litmus test for IaaS is this: do you have a unique, non-negotiable requirement at the hardware or operating system level? Are you migrating a complex legacy system you can't change? Are you building something so new and so custom that no existing platform can support it? If you answer yes to any of these, you are squarely in the land of IaaS. You are trading convenience for absolute necessary control. Now let's slide over to the middle of our spectrum: This is the sweet spot of balanced power and productivity. This is PaaS. Platform as a service is for the creators, the developers, the teams whose primary goal is to build and ship software fast. They don't want to build the house from scratch, and they don't want a fully furnished apartment. They want the perfectly prepped artist studio. The walls are primed, the lighting is installed, the plumbing works. All they need to do is bring their canvas and paints and create their masterpiece. The most classic use case for PaaS is modern web application development. Think of a startup trying to build the next big social media app or e-commerce platform. Their competitive advantage isn't their ability to patch a Linux kernel or configure a virtual router. Their advantage is the unique features of their application. They need to be able to write code, test it, and deploy it to their users multiple times a day. Using a PaaS, their developers can just write the code for a new feature, let's say a new recommendation engine, and with a single command push it. The PaaS automatically handles everything else. It provisions the servers, configures the database, sets up the load balancers to handle traffic, and scales the application up or down based on user demand. The development team can focus 100% of their energy on what makes their product special, not on the plumbing. This radically accelerates the pace of innovation. It's the difference between a pit crew that has to build the car before every race versus one that just has to fine-tune a high-performance engine. PaaS is also the engine behind the API economy. When a company like Stripe provides a simple way for any developer to add payment processing to their app, they are providing a PaaS-like experience. Developers interact with a clean, well-documented platform without ever having to think about the incredibly complex infrastructure handling billions of dollars in transactions behind the scenes. So the litmus test for PaaS is this. Is your main goal to build, deploy, and manage an application as quickly and efficiently as possible? Are you working with standard programming languages and frameworks? Do you want to abstract away the underlying infrastructure so your team can focus purely on writing code and delivering features? If so, PaaS is your creative studio. It offers the perfect trade-off. You give up some low-level control, but you gain a massive boost in speed and productivity. Finally, let's slide all the way to the right end of the spectrum, maximum convenience. This is the world of SaaS. Software as a service is for everyone else. It's for the end users, the businesses, the individuals who have a problem to solve and just want a tool that works right now with zero fuss. You don't want to build a house or design a room. You just want to move into a fully furnished, all utilities included apartment and start living. The use cases for SaaS are quite literally all around us. It is the air we breathe in the digital world. When your company uses Salesforce to manage customer relationships, that's SaaS. You don't download software. You just log in through your web browser. When you collaborate with your team on Slack or Microsoft Teams, that's SaaS. When you store your files in Dropbox or design a presentation in Canva, that's SaaS. The defining characteristic of SaaS is that it solves a specific, end-to-end business or personal problem. You don't get building blocks. You get a finished product. Think about accounting. A small business could, in theory, use IaaS to build a server, install a database, and write custom accounting software. Or they could use PaaS to build a slightly more streamlined version. But why would they? Instead, they can subscribe to a SaaS product like QuickBooks or Xero for a small monthly fee and get a world-class, constantly updated accounting solution instantly. They are outsourcing the entire problem to experts. The power of SaaS is its ability to democratize incredibly sophisticated software. Enterprise-grade email, file sharing, video conferencing, project management. These were once the exclusive domain of giant corporations with huge IT budgets. SaaS makes them accessible to anyone with a credit card and an internet connection. So the litmus test for SaaS is the simplest of all. Are you looking for a ready-to-use tool to solve a specific problem? Do you want to avoid any and all responsibility for managing software, servers, or code? Is your top priority ease of use, low upfront cost, and immediate value? If so, you are a SaaS customer. You are choosing to trade all control for the pinnacle of convenience. Now, here's the critical real-world insight. It's almost never an either slash or choice. The most successful and sophisticated companies don't just pick one. They use all three, creating a hybrid strategy that matches the right model to the right job. Imagine a modern online retail giant. They might use a SaaS product like Workday for their internal HR and payroll because it's a standard business function, and there's no reason to reinvent the wheel. Their main customer-facing e-commerce website, however, might be built on a PaaS. This gives their development teams the agility to rapidly release new features and the auto-scaling capabilities to handle the massive traffic spike on Black Friday. But deep in their technology stack, They might have a highly specialized, custom-built fraud detection system that requires immense, fine-tuned computing power. For that specific component, they use IaaS, giving their data scientists the granular control they need to run their complex machine learning models. SaaS for standard operations, PaaS for rapid innovation, and IaaS for specialized, high-control workloads. This is not a choice of one versus the others. It's a strategic combination, a carefully selected toolkit where each service model is a different tool used for a different specific purpose. Understanding this mix is understanding the heart of modern cloud strategy. So we have the what: infrastructure, platform, and software. And we have the how, the strategic choice along the spectrum of control versus convenience. But that leaves one massive, fascinating question. Who? Who are the colossal titans of industry building these global-scale platforms? Who are the companies locked in a high-stakes battle to become the landlord, the architect, and the property manager of the entire digital world? That's a story of power, competition, and technological warfare. In this new digital landscape, three colossal empires have emerged, each vying for supremacy. These are the titans of the cloud, the behemoths who have spent hundreds of billions of dollars laying the digital bedrock for our modern world. This is the story of the cloud wars. First, let's talk about the accidental king, the one who started it all, not through some grand strategic vision, but by trying to solve a completely different problem: how to sell more books. I'm talking about Amazon. In the early 2000s, Amazon.com was growing at an explosive rate. Their internal infrastructure was a chaotic, tangled mess. Teams were stepping on each other's toes, and preparing for the holiday shopping rush was a yearly nightmare. To fix this, they embarked on a massive internal project to build standardized, automated, and incredibly scalable infrastructure components that any team inside Amazon could use on demand. They built a system where a developer could request a server, a database, or storage with a simple click, just like a customer orders a product on their website. And then one day they had a stunning realization. The most valuable product they had built wasn't their e-commerce store. It was the very foundation the store was built on. They realized that if their own internal teams found this on-demand infrastructure so useful, maybe other companies would too. In 2006, they launched Amazon Web Services, or AWS. The world had never seen anything like it. They basically put their internal toolkit up for sale, renting out their servers and storage by the hour. This was the birth of modern IaaS. They had a 7-year head start on any serious competitor. 7 years. In the tech world, that's an eternity. While everyone else was still selling software in a box, AWS was building a global empire of data centers, becoming the default landlord for a generation of startups. Netflix, Airbnb, Pinterest, Slack, they all built their businesses on the back of AWS. Why spend millions on your own servers when you could rent from the best and scale up or down instantly? AWS defined the market, and to this day they remain the undisputed leader in market share. They are the original, the biggest, and the one everyone else is chasing. But if AWS is the established king, then our next titan is the relentless empire striking back: Microsoft. For years, Microsoft watched AWS from the sidelines. They were the undisputed rulers of the on-premise world. Nearly every company on Earth ran on Windows Server, used Microsoft Office, and relied on their enterprise software. They were a giant but a slow-moving one, and they were in danger of becoming a relic of a bygone era. The world was moving to the cloud, and Microsoft was being left behind. Then a seismic shift happened inside the company. Under the leadership of their new CEO, Satya Nadella, Microsoft went all in. It was a bet the company moment. The new mantra was cloud first, mobile first. They poured billions into their own cloud platform, which they called Azure. But they couldn't just copy AWS. They had a different advantage. Their secret weapon was their deep, existing relationship with virtually every Fortune 500 company. They went to these businesses and said, "Look, we know you're not going to throw away all your old servers overnight. That's okay. We have a solution for you called the hybrid cloud." They built tools that allowed companies to seamlessly connect their old, on-premise data centers with the new, powerful Microsoft Azure cloud. It was a brilliant strategy. It met customers where they were, providing a gentle on-ramp to the cloud instead of a cliff. For any company already invested in the Microsoft ecosystem, choosing Azure was the path of least resistance. It integrated perfectly with the tools they already knew and used. Microsoft leveraged its legacy dominance to stage one of the most incredible corporate comebacks in history, rapidly closing the gap and securing its position as the clear number 2, breathing down AWS's neck every step of the way. That brings us to our third titan, the genius in the room who was so far ahead they almost missed the race entirely, Google. Think about it. Long before AWS even existed, Google was solving cloud computing problems at a scale nobody could even comprehend. How do you index the entire internet? How do you serve billions of search queries a day? How do you store and stream every video uploaded to YouTube? Google had already built one of the most sophisticated, powerful, and efficient computer networks on the planet for its own internal use. They were living in the cloud before the term was even popular. Their platform, the Google Cloud Platform or GCP, is by many accounts a technical masterpiece. They are pioneers in areas that are now shaping the future of technology. Kubernetes, the open source system that has become the gold standard for managing modern applications, that was invented at Google. Their expertise in data analytics, artificial intelligence, and machine learning is arguably second to none. So why are they in third place? Because for years they didn't really treat the cloud as a product for outsiders. It was their internal secret weapon. They were late to the game in building out the sales, marketing, and enterprise support organizations that businesses demand. They had the best engine, but they were slow to build the rest of the car around it. Today, that has changed dramatically. They are investing heavily and fighting fiercely for market share, positioning themselves as the high-tech, innovative choice for companies that want to leverage the same cutting-edge infrastructure that powers Google Search and YouTube. So you have the three giants: AWS, the undisputed market leader and trailblazer; Microsoft Azure, the enterprise powerhouse and fast follower; and Google Cloud, the technical prodigy playing an aggressive game of catch-up. Together, these three companies control over 2/3 of the entire global cloud market. Everyone else, companies like Oracle, IBM, Alibaba, are fighting for the scraps. This isn't just friendly competition. It's a full-blown war fought on multiple fronts. There are constant price wars, where one provider will slash the cost of a popular service, forcing the others to follow suit within hours. There's a feature war, a relentless arms race to release the newest, most advanced services in AI, serverless computing, and even quantum computing. They are locked in a brutal talent war, poaching the world's best engineers from each other with staggering salaries. The stakes are astronomical. We're not just talking about billions of dollars, we're talking about trillions. The company that dominates the cloud will hold the keys to the next generation of technological innovation. They become the digital landlords for the entire global economy. These three companies have built the foundational utility of the 21st century, as essential as electricity or water. They own the ground upon which the digital world is built. But this incredible concentration of power raises a new critical set of questions. With these titans locked in a battle for total control, what does that mean for the rest of us? For the businesses that depend on them, for the developers who build on their platforms, and for you, the end user whose digital life runs on their servers? Choosing a provider is no longer just a technical decision. It's a strategic alliance with a global superpower. And as we'll see, navigating this new world comes with its own set of incredible opportunities and hidden dangers. So let's talk about those dangers first. The biggest, most insidious one is called vendor lock-in. Imagine you build your entire pizza empire using that amazing proprietary magic pizza oven from Pizza as a Service. It makes the best pizza in the world, but it only works with their specific, patented dough, their special sauce, and their unique cheese. Your business is booming. But then one day they decide to double their prices. What do? You can't just switch to a different dough supplier. Your entire operation, your recipes, your staff training, it's all built around that one magic oven. Moving to a new provider would mean rebuilding your entire business from the ground up. That's vendor lock-in. In the cloud world, this happens when you build your applications using services that are unique to a single provider. Amazon's AWS, for example, has an incredible array of powerful services, but many of them, like Lambda for serverless computing or DynamoDB for databases, don't have a direct one-to-one equivalent with Google Cloud or Microsoft Azure. If you build the core of your company on these proprietary tools, you are deeply entangled with that provider. The cost and complexity of migrating away can become so astronomical that it's practically impossible. You're stuck. You've traded convenience and power today for a loss of freedom and negotiating power tomorrow. It's a deal with the devil that thousands of companies unknowingly make every single day. The second danger is even bigger, and it plays out on a global stage: data sovereignty. When you put your data in the cloud, it doesn't just float in some ethereal digital space. It lives on a physical hard drive, in a physical server rack, inside a physical data center, located in a specific country, subject to that country's laws. If your business stores its data on AWS servers in Virginia, it falls under United States jurisdiction. That means it could be subject to U.S. government subpoenas or national security letters. If your data is on an Azure server in Germany, it's subject to German and EU privacy laws like GDPR, which are much stricter. This creates a geopolitical minefield. What happens if your company operates in a country that has a political falling out with the country where your data is stored? Could your access be restricted? Could your data be seized? These are no longer hypothetical questions. Governments around the world are waking up to the fact that data is the new oil, and the nations that house the data centers hold immense power. Choosing a cloud provider isn't just about picking the best tech. It's about choosing which legal and political ecosystem you want your most valuable asset, your data, to live in. But for every danger, there is an incredible opportunity. The very centralization of power that creates these risks also enables solutions that were once unthinkable. The answer that the smartest companies are now embracing is not to pick one king, but to strategically use several. This leads us to the concepts of multi-cloud and hybrid cloud. Multi-cloud is exactly what it sounds like, using multiple public cloud providers simultaneously. Why would you do this? To avoid that dreaded vendor lock-in. You might run your main application on Microsoft Azure because you like their PaaS offerings, but use Google Cloud's BigQuery for your data analytics because it's the best in the world at that specific task. And you might use AWS for long-term data storage because their S3 Glacier service is incredibly cheap. By using the best tool for each job from different providers, you create a system of checks and balances. You're not beholden to any single company's price hikes or policy changes. You keep them competing for your business, which drives down your costs and drives up their innovation. It's a more complex setup for sure, but it gives you ultimate flexibility and control. Hybrid cloud takes this a step further. It's a mix of a public cloud like AWS, Azure or Google, and a private cloud. A private cloud is essentially your own data center, your own on-premise servers that you own and manage, but built using cloud technology and principles. Why would anyone still want to own servers in the age of infinite public cloud? For security and regulation. A bank, for instance, might be legally required to keep its most sensitive customer transaction data on its own private servers, inside its own building. But it still wants to take advantage of the public cloud scalability for its public-facing website or its mobile banking app. With a hybrid cloud strategy, they can. They keep the crown jewels locked in their own private vault, while using the public cloud's vast resources for everything else. It's the ultimate best of both worlds approach, combining the security and control of on-premise infrastructure with the power and flexibility of the public cloud. This is the strategic reality of cloud computing today. It's not just about IaaS, PaaS, or SaaS anymore. It's about creating a sophisticated, resilient infrastructure tapestry woven from all of these models, across multiple providers, tailored to the specific needs of the business. And the evolution doesn't stop there. We are now entering the next era, pushing beyond the boundaries of these three foundational layers. The first frontier is serverless computing, also known as functions as a service or FaaS. If IaaS is renting the hardware, and PaaS is renting the workshop, serverless is like having a magic robot that appears, performs a single task, and then disappears, and you only pay for the exact milliseconds it was working. You don't manage servers. You don't manage operating systems. You don't even manage application runtimes. You simply write a small piece of code, a function, that does one specific thing, like resizing an image after it's uploaded, or processing a payment. When that event happens, the cloud provider instantly spins up the resources to run your code, then shuts it all down the moment it's finished. This is the ultimate form of abstraction. You are no longer concerned with infrastructure at all. You are only concerned with the logic of your code. It's incredibly efficient and cost-effective for certain types of workloads, and it represents a radical shift in how we think about building and deploying software. The second, even more mind-bending frontier is edge computing. For 2 decades, the story of the cloud has been about centralization, moving everything into a few dozen massive hyperscale data centers around the globe. Edge computing completely flips that script. It's about moving compute power and data storage away from the centralized cloud and closer to the edge, where the data is actually being generated and used. Think about a self-driving car. It generates terabytes of data every single day from its cameras, LiDAR, and sensors. It needs to make split-second decisions like whether to brake or swerve. It cannot afford to send that data all the way to a data center in another state, wait for a response, and then act. The latency would be catastrophic. The car itself needs to be a powerful mobile data center. That's edge computing. Think about smart factories where robots need instant feedback to adjust their movements. Think about augmented reality glasses that need to overlay digital information onto the real world with zero lag. All of these technologies require computation to happen locally, right at the edge. The central cloud won't disappear. It will become the core for massive data analysis and long-term storage, while the edge handles the immediate, real-time processing. The future, then, is a decentralized web of computation from the massive core to the billions of tiny devices at the edge. So let's bring it all home. We started with a simple pizza. We saw how you could make it yourself with raw ingredients. That was your on-premise server. We saw how you could rent the kitchen and oven infrastructure as a service. We saw how you could just bring your secret recipe and have someone else handle the kitchen and the cooking platform as a service. And we saw how you could just order a delivery software as a service. But now we see it's so much more than that. It's about choosing which kitchen to rent, knowing you might get locked into their special ovens. It's about deciding whether to use multiple kitchens in different neighborhoods to get the best of everything. It's about deciding which ingredients are too sensitive to ever leave your own house. And it's about a future where tiny magical pizza ovens might appear on demand to cook a single slice, or where the pizza is actually cooked in the delivery car on its way to your door. Understanding IaaS, PaaS, and SaaS is no longer just a technical detail for IT professionals. It is the fundamental grammar of the modern digital world. It dictates how businesses are built, how applications are delivered, and how data flows across the globe. It is the invisible architecture behind nearly every single tap, swipe, and click you make. The next time you stream a movie, order a ride, or collaborate on a document, you now know the secret. You're not just using a service, you are participating in a vast, global interconnected system of rented kitchens and delivered pizzas. A system that is constantly evolving. A system that is fundamentally reshaping our world in ways we are only just beginning to understand.